I think one could say that the appearance of big data is, as we all know, a big opportunity for the NSOs, and we have been working with it for quite some time. But we also know that it's a challenge. It's a challenge in relation to get experiences with it and to share those, but it's also a substantial challenge in relation to training and the development of training materials, which is what we will be looking at during this side event. We have, as the Global Working Group, had a number of training activities in relation to the yearly conferences that we were able to organize in the years before the COVID. In relation to most of those, there were also training activities, and training is also an important part of what will be going on in the regional hubs that we are trying to set up. But we do also have a very active task team on training activities that has done a lot of work in the recent years, and that's part of what we're going to listen to today. We have 3 presentations, one on the work of the task team, one on the training program for Earth observation, and one on training courses on privacy preserving techniques. And after each presentation, there will be a question and answer session. You can post your questions in the chat, and we will try to keep kind of track of that and read them loud for the presenters and for others, and in that way have the interaction between the presentations and the participants. So very welcome to this side event, and I will pass the floor on to Sverre and Dominika, who will do the first presentation. Please, the floor is yours.
Apologies. Can you see my screen?
Yes. We just need to put it in presentation mode.
So there?
Exactly.
Okay. So thank you, everyone. Thank you for joining us. My name is Kerry Regan. I'm a Programme Manager in the Data Science Campus in the Office for National Statistics in the UK. And my colleague, Dominika Nowak, is Head of Experimental Research at Statistics Poland. We're both members of the UN task team on training, competencies and capacity development. And we're going to share with you what we've been doing and what's coming. Hopefully, I mean, put your questions in the chat. We will get through as many as we can. If we can't get through them, we'll try and contact you all later with some responses. Okay, let's get going. So what we're going to do, we're going to share with you some of the things that we've done so far, a lot of the products and tools that we've created that should help the NSO and the individual. So we're going to share with you something that we did a little while back now, a institutional readiness for big data in official statistics survey. We're going to show you some screenshots of a maturity matrix and competency framework, and then we're going to talk about the training that's in development. Okay. So a little while back, we thought, well, let's just try to work out where everybody is at this point in time. So this is a couple of years ago now. We wanted to know where NSOs were on their big data journey. We decided to conduct a survey. And you might think, well, why weren't you a bit more creative? Why weren't you more innovative? You're trying to capture big data science activities. Well, to be fair, we couldn't find the data that we needed anywhere else. We couldn't have scraped it from websites, so we ended up doing a survey, which isn't ideal, but hey, it was a good result. If you like, we did this capacity of NSOs against 4 dimensions: their strategic data science coordination at the NSO, how the legal framework was structuring for data access and sharing, how was the IT infrastructure taking shape for the capacity of big data storage and analytics, and what was happening with human resources, how were the skills, how was recruitment, those sorts of questions. We issued this globally to 160 NSOs, and response rate was pretty good, 63%. Could have been better, but we were happy with what we had. So thank you to all those who did respond at the time. What came out of that has informed a lot of the work that the task team has now taken forwards. There are some challenges were identified. How do you obtain big data sources outside of government? A lot of the legal frameworks that were in place were there for statistics, but not for big data applications. So some work needed to be done. In terms of the IT, data storage, it could be off-site or on-site, processing power were challenges for many NSOs, and few were considering secure cloud. But the bit that we were most interested in, because of our title of our task team, was around human resources. Most NSOs were keen to upskill analysts to become big data experts or data scientists, but most were lacking a competency framework or a way forwards, or a recruitment approach or a pot to recruit from. So these were the challenges we tried to pick up and address. What came out was that some of the issues were either organizational level, so NSO level issues, or they were individual level. So we've tried to break this down. I hope this diagram sums it up. So on the organizational level, this led us to think, well, okay, let's try to develop something that helps the organization identify its gaps in where it wants to be. And the same on the individual level. How can an individual sit down and think, this is where I want to be, these are my gaps? So for the organizational level, we came up with a big data maturity matrix document, and for individuals, a competency framework. So that's all about gap identification, which then will lead on to getting some guidance, some training, etc., so you can start to fill the gap. So what we're going to speak to you about next is these two documents that we came up with. So the maturity matrix and the competency framework. So the maturity matrix is all about trying to establish where the strengths and weaknesses are for the organisation, and that can be used to develop roadmaps, strategic plans and training programmes for where the NSO wants to get to. And Dominica will share with you the competency framework, which is about identifying gaps in skills and competences. And it all links through to training at the end of the day. So the maturity matrix is already available as a PDF document on the UN website. We want to take that one step further, and we're in the process of doing that. It is being moved currently to an online, interactive, intuitive tool. And there's an option there to submit your results to the UN. The idea being here, we don't want to have to keep reissuing the survey that we did a couple of years ago. So if now there is a way that we can capture information on an ongoing basis, that will help relieve that burden of having to complete a survey every couple of years. So the maturity matrix picks up on the 4 dimensions that we mentioned earlier: legal frameworks, IT infrastructure, human resources, also applications in projects. What are NSOs doing in applying this in their work? There are 3 steps to the maturity matrix. The first one is that it's an NSO tool, it's organizational level. You set the goal of where you want your organization to be in terms of big data. You then answer some questions against the 4 dimensions, and the results will show you where you actually are. And then you've got your gap identified. And a future link is that gap will come up with some recommendations of training and guidance and advice for how to move forwards to get to where you wanted to get to. I'm going to share some screenshots with you of how this is looking. So this won't be long, and it will be available on the UN website. So there's a little bit of blurb on the introductory pages around what this is, what's it all about. And then you can see step 1 is around setting your goals for the NSO, and then step 2 is the assessment. So let's have a look at setting your goal. And you would set your goal against those 4 dimensions, setting where you would like to be. Then you answer questions in those 4 dimensions, and that will tell you where you currently are. And you'll get a readout that might look something like this. And the orange vertical lines are the goals that you set for your NSO. And you can see on this particular example that we've mocked up, there is some gap with the legal and policy framework dimension. Now, at this point, you can, if you want to, submit your results to the UN so they can see where you are and they can see where more assistance is needed. And the future step 4 for this would be around that gap identified, linking to some advice, guidance, training courses that will help the organisation move and fill that gap. So that's the idea. Of course, we want everything eventually to link to training programs and guidance materials. So that's the long-term goal. Okay, that's enough on the maturity matrix. I'm now going to hand over to Dominika, who is going to share with you the competency framework.
Thank you. So I would like to say a couple of words about the competency framework, which addresses the level of individuals or employees at an NSO. The framework intends to provide a general guideline on the skills which are necessary to build big data competencies. Now, of course, the term big data competencies might be disputable because there does not exist a universal set of big data skills. And yes, there are different types of data specialists. We have data engineers, data analysts, data scientists, and these roles become even more granular and specific if they are applied to work with different data sources. For instance, processing streamed data from AIS is not the same thing as processing scraped data. And there's also an issue of different stages of the statistical production process. So these are just a couple of issues that sort of shape the background of the work on the competency framework, and show how complicated it was to conceptualize the approach to this framework on the one hand, while at the same time making it as universal and as much useful for a large group of different NSOs as possible. And there was actually no other way than employing some simplifications, not going into extreme detail or giving up from referring to each specific data source or project. So keeping all these challenges in mind, in the framework, there have been employed 2 approaches. The first approach involves presenting big data competencies according to general blocks. The competencies here have been divided into 2 groups. So we have core competencies or technical skills and generic or soft skills. And the second approach involves graphical representation of the competency blocks according to the simplified statistical production process. Now, next slide, please. Now, I will not go into detail on each of the competency areas, but I will just try to give you a short overview of the approach and the format we employed with the expectation of making this framework as useful as possible. So we distinguish 7 blocks of core competencies. So these are ethics and privacy, mathematics, data management, statistics, programming, machine learning, and data visualization. Obviously, these areas are not exclusive, and most of them intertwine some with if not most of the other areas. For example, programming will be part of data management, ML, data visualization, etc. So let's move on. Each of the competency blocks presented according to the was presented according to the format that you can see here, which includes 4 dimensions. The first dimension is simply the name of the area. So here we have ethics and privacy, data management, programming, and so on and so forth. The second dimension is a description of the competencies identified as crucial or dominating in the area. Next dimension specifies 3 proficiency levels. So we distinguished between foundation, intermediate, and advanced level. And finally, the 4th dimension breaks down the competency area into knowledge, skills, and attitude with some examples. And next slide, please. Here, for example, is the description of data management competency areas, and all other areas or blocks look pretty much the same in terms of the format. Let's move on. So beside core or technical competencies, the framework includes generic skills, which of course are indispensable in the whole big data competency landscape. They extend across all stages of the production process, and well, they are something very natural and intrinsic to the whole spectrum of big data competencies. And the framework, actually for this very reason, does not elaborate on them too much. They are instead just briefly described following the core skills. Yeah, so now the next slide, please. So we distinguish 9 areas of soft skills. We're not trying to say that this list is exhaustive, and there might be quite a lot of alternatives here, but this is the result of a round of consultations across NSOs and task team members. So here we have such areas of generic skills as agile project management, adaptability, business acumen, communication, critical thinking, curiosity, product understanding, storytelling, and team player. Right, all right, now stepping from the competency blocks approach, we intended to match the competency blocks with a simplified statistical production process. And on the next slide, we can see the outcome of the attempt. So what basically becomes apparent from this graphical representation is that most of the competency blocks span various production stages, and so do generic skills. And we believe that this process approach should help discern the complexity of big data competencies, also facilitating the development of big data competency plans for individuals in the organization. Let's move to the next slide. So starting with a high-level assessment of organizational readiness for big data, which Carrie was talking about, we then attempted to go down to the level of the organization, to the level of the NSO, and here address the need to face the challenges related to the organizational capabilities and related to the individual employee. Let's move on. So, so those were the starting points. We began with the assessment and gap identification tools and guidelines. And building on those developments, we moved to searching for the solution which would enable the NSOs to address their needs. And now we will briefly go over the work of the task teams, which is underway. So what will come next is the big data training catalog, big data curriculum, and finally our ambition is the development of the training courses, bearing in mind the overarching goal of not leaving anyone behind. So the first step is to check out what is available out there, which means identifying the training courses and other resources available in many different places and pulling them together in a tool whose working name is the training catalog. In this respect, there's been a great chunk of work done by the Earth Observation Task Team, and I believe we'll hear more about the approach and the tool in the next presentation. So the goal here is to bring the catalog as soon as possible to an accessible area within the UN, such as the UN Global Platform, and expand it by adding more links to the subject matter courses, preferably corresponding to the topics leading in the UN Global Working Group, such as AIS, scanner data, and so on. So this is one of the areas of the work in progress. And now over to you, Carrie.
Thank you, Dominika, and I apologise, the slides kept moving forwards themselves without me touching. Apologies for that. Yeah, so building on that is also the development of a training curriculum, which is not an easy task, we have discovered. You can see down the side here on this slide, these are all of the task teams that currently exist. Earth observation data, privacy preserving techniques, scanner data, AIS, which is the shipping data, mobile phone data, and SDGs. The plan is to make sure that each of those task teams has a curriculum and catalogue of what is already out there. Our role then will be to pull all of that together into one overarching curriculum that maps to the competency framework and maturity matrix, delivers training for different user profiles and knowledge areas, establishes what we would deem to be critical or essential learning, but also there will be common topics that run across all of these, like Python, machine learning, etc. So there's quite a lot of work to be done here. But as Dominika hinted at, the Earth observation task team has done some amazing work here already. So for us, it's about taking what has been done, extending that across all of the other task teams and scaling it outwards. The aim is for one training catalogue that covers all of the task teams, all of the topics, all of the big data topics, and all of the data science areas that you would expect to see in a curriculum. The aim is also to have foundation level training available as soon as possible. And today you're going to hear from the privacy preserving techniques task team, because theirs is already done and they are going to share that with you today. We are also in the process of establishing a learning management system that we hope will sit on the UN Global Platform that is going to host all of this training. The plan is that obviously that will link to the curriculum and the catalogue, but that it will provide you with something that is searchable. Now, on there will be training courses that already exist. They're already out there at this point in time via Coursera, DataCamp, etc. But it will also link to these new UN courses which are being developed by the task teams that cover all of those topic areas. It will be searchable. You can input what you're looking for and you will get recommendations out for training that already exists. Another aspect of this system is that you will be able to make it personal to you. So similar to what we did with the maturity matrix, it will be a personalized system which allows you to say, this is what I aim to achieve. This is where I currently am. And the catalogue will provide you with training courses which will allow you to go on those steps to where you want to be. That's the plan. And again, the Earth observation task team have already made a fantastic start on this type of searchable, personalized catalogue, and hopefully they'll share that with you in a moment. This is my final slide. Our final slide is just on the useful links around Big Data website, where you can go and find the maturity matrix, competency framework, and a link to the report that came out from the readiness assessment. and also a link to our task team page. And I will stop there. Many thanks for listening.
Thank you very much. Very nice presentation, impressive work that you have done, all the achievements and the tools, and a very good plan also for the future. There are a number of, there's a few comments in, in the chat. One of them, as far as I can see, oops. That was. One is, how can those in academics who are not yet part of the committee or task force contribute to building these curricula? If you could speak to those pathways, that would be much appreciated.
Oh, we actually have somebody from academia assisting us with the curriculum development. And so I'm hoping that that will bridge that gap quite neatly.
Okay, thank you. And there at least one raised hand. And if it's possible to unmute the mic, then please, Karen, pose your question. I was told that it might not be possible to unmute the mic, but if you can, please go ahead.
No.
You can't. No. But then you can post a question in the chat.
No.
Oh, okay. I can't find the chat on this to post a question. I simply wanted to know, are the slides going to be available?
They will.
Okay, thank you.
There's also a question in the chat saying, in your opinion, is there any subfield of data science that mostly or only a statistician can get hold of to be the subject matter expert? Should I read it out again?
I'm not sure I understand the question.
Yeah.
If there's any subfield that mostly or only statisticians can get hold of to be the, I guess the question is there an area of what you've been looking into that is kind of, maybe rephrasing it, more important for official statistics than others?
I'm not sure if I can answer the question.
So we should basically think if there is some exclusive area of a data science which relates specifically to statisticians. If this is the idea here, then I couldn't think of any specific exclusive area.
Okay, thank you. There are no more questions in the chat, as far as I can see.
There's one asking if training will be publicly available. Yes, we're hoping it will be via the UN Global Platform. The idea is to make it accessible to all.
There's also another comment saying, do I understand it correctly that the whole curriculum will focus mainly on data processing, but not so much on pre-steps of data collection?
There may be something around data acquisition.
That was actually the legal part of it, for instance.
Yeah.
Yeah. Okay. Ronald, you raised your hand and you might be in a position that you will be able to actually unmute your mic.
Yes, I hope you can hear me.
Yes.
So thanks, Carrie and Dominica, for the presentation. Maybe that question about how statisticians fit in is maybe more broadly on the topic of this is now an area where statisticians will work with a lot of other community stakeholder communities. So how do you see this? So this is a development. We now have, like Carrie, you're working now in a data science campus. So we're reaching out to data scientists, more mathematicians, not the traditional statistics, if you like. So could you see within your discussions within the training and within the training team and with others, how the profiling of who's actually working now in this field is developing with data scientists, data engineering, statisticians? If you could speak to that, that would be great. Thanks.
Thank you, Ronald. Yes, so when we are looking at the development of the curriculum, we are thinking about who are all the different users that we need to think about developing. So the user profiles. So that might be statisticians, economists, other analysts, as well as engineers, etc. So we are trying to think about training being available for all different types of user that fit within the NSO, that fit within official statistics. Does that answer the question better?
Thanks. Yes. And also that's why I think we see now that statistical offices are opening up data science campuses and that kind of research just to broaden the scope of let's say staff they're working with. Yeah.
There's one last question, namely, would the training also deal with integration with the more traditional sources of statistical information?
You're muted, Carrie.
You're muted, Carrie.
Yeah, no, sorry, I was reading it.
Okay.
Dominica, does that fit with the competency framework? I think it does. I think that is an area that will be explored.
The integration with traditional sources, actually, I would see it as an addition to the basic training that we're because this is another layer. So at this moment we haven't looked particularly into the data integration, especially big data and traditional sources, but this is definitely something we should look into.
Yeah, this could be good feedback, actually. This could be an area that we need to develop further. Yeah, that's excellent. Thank you for that question.
Okay, thank you, and thank you very much for the presentation. We will now move on to the next presentation, which will be on the work on training activities for the task team on Earth observation, and it's another Carrie spelled a little bit differently. Carrie, please, the floor is yours.
Thank you very much. Can you hear me okay?
Yes.
Okay, great. Okay, so let me see if I can share my screen. Just bear with me for a second. Right. Can you see my screen?
Yes.
Good. Okay, so I'm Carrie Mangerson. I'm a professor of statistics at QUT, Queensland University of Technology in Australia. And this work is undertaken with my research assistant, Amy Stringer, and also Lorenzo De Simone in FAO. And we're the leads of the training program for the task team in Earth observation for agricultural production statistics. And so this program is undertaken in collaboration with the whole task team. And the task team is led by Statistics Canada. What I'd like to talk about then is the design of the training program that we've developed to propose to you and to others as a way forward for training in this particular area. So the task team terms of reference, an extract of that is to support member countries by helping to develop new methods for the collection, analysis and use of new data sources, such as Earth observation data, for evidence-based decision-making in support of national policies and international agreements. And the focus on the SDG, that should be goal 2, target 2.4, is by 2030 to ensure sustainable food production systems and implement resilient agricultural practices that increase productivity and production, that help maintain ecosystems, that strengthen capacity for adaptation to climate change, extreme weather, drought, flooding, and other disasters that progressively improve land and soil quality. And the indicator 2.4.1 for that target is the proportional of agricultural area under productive and sustainable agriculture. And so our task team then is looking for ways that we might use Earth observation data to be able to, for crop identification and also to predict crop yield. So that's the fundamental focus. And of course, then there are ancillary targets as well that we can address using these methods. So what we want to do then is we want to have analysis of Earth observation data, analysis-ready data, production-ready data, and we want to have satellite-based Earth observation data for estimation of crop types, areas and yields, and land use change. And we want those to be trusted methods. And we also want trusted training. So we want training material that we can trust and on the use of methods and algorithms to estimate crop types and crop yields.
Carrie,
so
can I interrupt? Sorry, Carrie, it's Ronald.
Yes.
We only see your first screen of the PowerPoint.
Oh,
we don't
no,
see your,
do you?
we don't see the presentation screen. Can you switch to that?
Okay. All right.
I
well,
think you're not in
I
presentation mode.
Yeah.
As far as I could see, I was. Let me try. Can you see my slides in that mode?
No, we just see the first slide. Yeah, now you move your slide in your PowerPoint, but not in presentation mode.
Okay, all right. So I'm going to go into presentation mode now. So I'll move from the slideshow from the beginning and tell me if you can see. Can you see the change of slides?
No.
Ah, okay. All right. Well, what I'll do is, can you see the change of slides now? Can you see the slides changing?
No, we just see your PowerPoint, but not the presentation mode. We see the PowerPoint and we see now slide number 2 in terms of reference.
Okay, that's the slide number 2. But what I'll do then is, when I go to put it into presentation mode, like the slideshow, it's not showing it. So what I'll do is just go through it like this. Is this okay with you? Can you see it?
It's okay.
Yeah, that's fine.
Okay, I think that's easier rather than me trying to figure that one out right now. Okay, so what I want to show you then is we have the trusted methods and trusted training. The training approach then is the phase 1 is to take an approach where we define the user profiles and the knowledge areas, then to collate existing online training courses from trusted sources and to collate those and make them searchable, to create a personalized training program based on the existing courses, and then to develop a course feedback system. Phase 2 then will be to add a spine of bespoke UN short courses to introduce the training modules and to provide context. So I'd like to talk about where we're up to in this. So our first stage then first action was to define user profiles. And the first 3 user profiles that we started with were managers, GIS experts, and data scientists. We then looked at knowledge areas. And so for this particular task team, the knowledge areas in EO for agriculture were around software, visualization, remote sensing, GIS, data management, and data analysis. We then searched the available courses, online courses, of which there's very many, and we categorized those courses with respect to the source of the course, the timing of the course, the software that was used, the level of the course, the professional background that was required, and who that course would be targeted for. So we have a role of the course, the professional background, we have the use cases that were considered in that course, the software, the programming language, and so on. So for each of these courses then, we could map them to the knowledge areas. And so you can see here, for each of the knowledge areas, we broke this down into the main goal, and then the fundamentals, introductory, intermediate, and advanced courses. For each one of these, then, if you just look at blowing that up, so for the remote sensing module, the fundamental course you can see is the fundamentals of remote sensing. We then have the introductory courses around satellites and sensors, precipitation and soil moisture, data products and indices, the intermediate courses then around various topics, and then advanced courses, which are around use cases with software, computation of indices, and more detailed examples. That then feeds through an integrated system of the overall goal, to the fundamental questions, to the introductory questions, to the intermediate questions, and to the advanced questions. And if we then just go into a summary of the courses, you can't see this very well, so I'll go to the, what we've done is we've collated all those courses, said where are they from, and then we've been able to expand that. So for example, these are the agricultural courses in the database, and if we expand that, you see that there's the different kinds of the provider of the course, the mode of the course, so how it is presented, what the actual course material was, and the timing, as said, and the level of the course and the software that's required and so on. So a lot of detail, a lot of metadata about these courses. Similarly then for spatial statistics courses and so on. So if we just take a look, for example, at a use case, this is a case that Lorenzo de Simone put together on crop mapping, and he has a toolbox sent to Agri. But in order to use this toolbox then, this kind of learning program can fit by saying, okay, what are the learning goals? And then what are the fundamentals? What is the introductory level? What's the intermediate level? What's the advanced level that would be associated with, for example, a toolbox like this? So you could come to this kind of program and you could ask, well, what's the, as a user, particular type of user, what kind of courses, I can search this database to say what kind of courses are going to suit me at a particular level. Or I could come to this saying, I want to be able to use this particular toolkit, and what kind of courses or training would I need in order to be able to use this? So there are various ways that this kind of database could be used. So we then have now the ability, if we have this database and we have it searchable by keywords, we can then construct a personalized self-learning system. So if we have a selection of user profiles and a selection of knowledge areas, what we can do is we can ask an individual, what is your role? And then where are you now with respect to different areas? For example, in programming, data acquisition, data processing, data analysis, GIS, and so on. And where do you want to be? What skills do you want to acquire? And so in this way, we can then map this to the database and recommend a set of courses. Those recommended courses then will appear, and you can select the particular courses and add them to your shopping basket, so that at the end then you end up with a set of courses that are targeted to your particular learning aims. If we do that, then we, in the next phase, what we'll do is add a training spine. So these will be the particular core courses that we will create that will link to these open software modules. So for example, we would add a spine course which would talk about just the fundamentals of remote sensing and give an overview of this and talk about how it relates then to Earth observation and agriculture. So it's more specifically for the UN and the official statistics audience. So the next phases now in what we are developing is to add other courses to our database, so add regional hub courses, and then link to maturity matrix and competency framework. We want to also create a recommender system. So this will be a system whereby, if you look back here at the this particular slide, this is a course feedback slide. So for every course, we've developed this way of saying, you know, how would you rate this course overall? Based on your role, how relevant did you find it? Based on your starting point, how did you find the pace of the course, and so on. From this, then, we can tailor or adapt the database that we have, but also we can have a recommendation score. So much the same, you know, people who participated in this course gave it a rating of 3.5 out of 5 or 4 out of 5. We're used to seeing these things now. And so in this way, then, the more useful courses will rise to the top of the database, and that will be helpful for the other users of the course. What we would also like to do is to create a facility to add courses, so people could then propose courses, and through a curation process, they can be added to the database. And after this, then we need to pilot the program and obtain feedback, and also to discuss certification and credentialing, and then to embed this in the UN Global Platform. Now, with permission, I'd like to take another just 5 minutes to show a short video of this system in play. Would that be okay? Do we have time, or shall I leave it there?
Yes, we have. Please go ahead.
Okay, thank you. So let me just go to the where I want to be. And hopefully this will work. Right, can you see this screen? It says, welcome to the course search and evaluation tool.
Yes.
Okay, good. All right. So, so now if I can get this to work. Okay, so this is a, this has sound, and I'm happy to share the video, but in the moment I'll just describe what this is. So this is our website at the moment, or the app at the moment, and you can see that there are 3 sections to this. There's the search engine section here, and the search engine section has a keyword course search, so you can then add the keywords, for example, what you're interested in finding. So this is, for example, data scientist, and then you can search on that. Through the database then come up all the courses that are related to data science, and you can see that there's 12 pages of those particular courses. So you might decide to refine that. So for example, regression, and up will come the list of regression courses. You can see here the different providers of the course, the different companies, and so on. If you don't put anything in the link in the box, then all of the courses come up. And you can see there's 13 pages of those. So this is a way then of being able to see what's in the database at the different levels. If you type in a wrong word, for example, potato, it says there's no data that's available in the table. So we will eventually have a list of potential keywords, so that you can't type potato, or you're less likely to type potato. The next section is about the personalized learning system. So now it says, tell me about you. Tell me about the kind of role you have. What are your core skills? How would you rate your current knowledge in the area? What kind of knowledge do you want to acquire? And you can see the kinds of things you can put into these boxes here at the moment. And again, this is a pilot system at the moment, so it requires some refinement, and we're very happy to take any feedback. Anybody who would like to participate, that would be great. So now what you do is you go to the course options, and based on what you've told us, then you get a set of recommended courses. So these are the courses that you might like to add to your personal profile. So you can select a course then, whichever courses you like, and you add them to your cart, to your personal profile. Then you can go to your personal profile and those courses will appear there. And this becomes then your personal learning program based on the information that you've given us. So what you then can do is, if you don't like one of the courses, you can remove it and so on. And then you can download those courses. So then you can save it in your system. Now, the other thing you can do then, let me just see if it's going to do that. The other thing that you'll be doing, I'm hoping, is you'll go to your personal profile. So you have a personal profile. After you've done that, then, as I said, there's this course evaluation form. So for the various courses that you've chosen, then you can take select the course, and then you can evaluate it. So you can give it various stars here. And then, as we said, this would then link to the recommender system that for the different courses. So based on your starting level, how do you find the pace of the course? How would you rate the clarity of the course, and so on? So this is the system that we have at the moment, and I'd be happy to take any questions on it. I'll leave it there.
Thank you very much, Kerry. Really interesting and very promising in relation to giving an easy access to an overview of training facilities. There are a number of questions already in the chat. One of them is a question I always pose to my staff when they present things for me, namely, when will it be ready? The second question is, can the kind of functionality that you have developed in relation to Earth observation training courses be used in the other areas of where we work in the Global Working Group, like scanner data or mobile phone data?
Yeah, so when will it be ready? What we'd like to do is, we'll firstly work with the regional hubs and other groups to ensure that we have the courses, the relevant courses in the database. We'd then like to have some volunteers so that we could pilot the system, so that we can showcase the system and get some feedback on it, and then work with the curriculum team to ensure that it meets the guidelines of the curriculum team, and also maps to the maturity matrix and the competency framework, and then to have it put up on the global platform. But anybody who's on this call, for example, who has any suggestions about other courses, would like to engage in the development of this, or would like to volunteer to trial it, I'd be delighted. So please just get in touch. The other question was about could this be mapped to the other areas? Yes. So you can see that it's a relatively straightforward system. Build a database, have it searchable, add this personalized profile. We've done this through our Shiny, so it's an app. It could also be built through another process as well. But yes, it's all able to be taken and used as a template for the other groups if that's of use.
Thank you very much. Then there's a question here, namely, is there any specific course on causality within the curriculum? And an additional comment, the academic literature and big data, there's an agreement that without causality, big data run into the risk of remaining associational. So basically, is there any course on causality within the curriculum?
At the moment, the courses are specifically around the EO data and the crop identification, crop yield. But I absolutely agree that in the broader context of the analysis of big data, then there needs to be, or any data really, there needs to be something about causality, as well as trust in the data, and potentially that comes into privacy and so on. So these sort of broader topics, I agree, but there's no reason that we can't build something like this around those broader topics as well, so that people could then choose something from the broader, as was discussed earlier, the sort of more generic skills and generic issues, to then the more bespoke issues that are around the particular task teams. So I'd be very happy to work with the person who talked about that to think about what those questions are, and I'm sure Kerry and the other team would also be happy to have that kind of input as well.
Thank you very much. Now let me see.
Hi, Niels and Kerry. Brian and Paul are unmuted, so if they want to ask their questions.
Exactly, but can they unmute? I don't know.
Yes, they can unmute themselves.
Okay, please pose your
Paul?
questions.
Yes, I apologize. I would have written this in the chat, but for some reason my chat option doesn't come up. So I apologize. I'm going to do it this way. Is there a bulletin board or some type of centralized location that we could look to see what other organizations are doing and maybe put informally what we're doing, so we could touch base with other people who are working with cell phones or, you know, that type of thing, so we can cross-fertilize what we're looking for?
I'm glad you didn't just put that in the chat, Paul. That's a great suggestion, and you know, and I hope that we can do that. You know, we've developed this well, relatively in isolation, and with some discussion with the other groups in conferences. But again, you know, we'd be delighted to learn from the other groups as well. So, great suggestion. I don't think it's something that I can do, unfortunately, but I'm hoping that it can be something that can be taken up by the larger group.
Okay, and there's one more who raised the hand, so please unmute and pose your question. If that is possible, I don't know if it is. Seems not to be the case. Okay, we have time for more questions, so please use the chat or raise your hand. Ronald, please.
Yeah, just to add on. So, Paul, I think you're Census Bureau, right? So we really like to see if the Census Bureau will work with us on this. And definitely, I mean, we have the task teams. I think Niels also mentioned it in the beginning. You can join in. I mean, certainly from the statistical community, but also even broader than that, can join in with the various task team. Academia, of course, carries from the academic side. We work with him closely. So yeah, and then a specific bulletin board. We've been using the wikis within our community. I don't know if that's the perfect way of communicating. We can use maybe other things, but that's something that we might discuss or might be discussed by this training task team. Just on that particular point. Back to you, Niels.
I would like to
Yes,
reach
please.
out to you on that, and a wiki would be a good start to keep kind of the technical issues that may not have been solved at the top, and share successes as well as failures, so we don't have to do the same thing. That'd be great.
Yes, please, Kerry.
I'm just looking at the comments in the chat as well, and I'm happy to answer some of those as well. But yeah, I can certainly add the link. I'm happy to, as you said, the courses on causality. I'm sure that you're reading these as well. But there was one on here about whether the database recognises or acknowledges or identifies free courses. Yes, it does. So it says, are these free or paid? In fact, what we did was preferentially look for open courses, because of course there's many universities that have courses as well, but we tried to look for courses that would be available. One of the other advantages of having this as a database system is that, as we said, we can add new courses, but also we can And I think that's really important. And we can also add different keywords and search terms as the course material evolves, as the area evolves, then we'll be able to add those courses. I still think there's a use for creating different databases, perhaps for the different task teams, as opposed to the one database to rule them all, just because there will be otherwise it becomes quite large and unwieldy. But then you can also have ways to connect those and to have potentially common frameworks, but maybe not necessarily either.
Thank you very much. If there are no more questions or comments, which seems to be the case, we will move on to the thank you very much, Carrie. Really interesting.
Okay, thank you. And if anybody does have any comments, please let me know, because we want to make this as useful as it is, and we obviously have many people here who can provide some great expertise. So really appreciate the opportunity to talk to you, but also appreciate your comments and feedback.
Thank you. So we'll now move on to the next and last presentation on the training courses on the privacy preserving technique, and that's Andrew. So Andrew, the floor is yours.
Thank you so much, and thank you. Can you hear me okay? Is it all
yes?
Coming through? Excellent. So I hope you're enjoying the session today, and I'm feel very honored to get to talk to you about the awesome courses that we've been working on. So today we're going to be talking about a series of courses that we're releasing on privacy preserving technique. So we're releasing 4 courses. We released the first one on January 2nd of this year. We've had almost 6,000 students register so far. So lots of good activity in the course. And so today what I hope to do is kind of give sort of a 2-part talk. So first talk a little bit about kind of the content that's in the course that's specifically relevant for the statistics community, and sort of get a sense for why we're putting these courses together. I'll share my screen, and then see if I can do this correctly. And then we'll talk about sort of the course modules themselves, and of course, if you want to get involved or take the course yourself, or have questions about the course construction techniques or how we set things up. We can cover that as well. Can you see my my screen okay?
Yes, we can.
Yes.
Excellent. Very good. Cool. So first, I'm going to walk through a little bit about what the courses are about and give you a little bit of a teaser for the type of content that's inside the course. And then we'll spend the last half talking about sort of the sort of meta level, how we're organizing the course ourselves, and the different programs, like we're for grading projects, and there's some technical mentorship, and it's like a live team of mentors that help with students with their projects, or if they get stuck, and give support in Slack as well. So lots of good exciting things. Cool. So we'll jump straight in. So for those of you who aren't familiar with privacy preserving techniques, the opening question to introduce this sort of course series and the topic that we're talking about is sort of, is it possible to answer questions using data we cannot see? So obviously, as statisticians and data scientists, there's the old adage that we spend 90% of our time sort of acquiring the data that we need, and 10% of the time actually doing the data science that we want to do. And that's kind of where the privacy preserving techniques start to become relevant. So let's say we wanted to answer the question, how many people were diagnosed with breast cancer last week in your own region? So like, if you're in Stats Canada or Stats Netherlands or something like this, and we wanted to answer this question, this is actually quite challenging, right? In the sense of doing it on this time scale, like specifically in the past week, might be quite difficult unless sort of very granular details have to be already available, right? So let's say you wanted to do this. Well, you could call every cancer center and ask. That would be a pretty big project, right? But before you do that, you need to find a list of cancer centers, and then before you do that, you need to get that permission to have the list. And this, has the potential to be sort of maybe a bit of a frustrating process. But there are different types of questions we might answer with data, such as, how many people were diagnosed with breast cancer last year? Well, this is quite a bit easier, right? Because we're sort of already collecting this kind of information typically on some kind of interval. I mean, I don't know if your particular statistics center does, but even if you weren't at a statistics center, this kind of information is broadly speaking available. And I think this is really, really important because there's sort of something natural about the way that data is laid out and the way that we access it as statisticians. That means that it's much easier to answer some kinds of questions, perhaps over longer time intervals, than it is to answer other types of questions, right? So, and this is because getting access to private or commercially valuable data can be really, really hard and really, really difficult. So there's like one group of questions which sort of fit a mold. So like if the data is not too personal, if it's sort of happening on an annual basis, meaning there's like a regular interval that I'm sort of contacting a large number of organizations to acquire a certain data set occasionally, such as, annual cancer statistics or something like this. In the case of COVID, obviously, we have massive infrastructure to do this at a much more granular level, but that infrastructure was pretty significant. But then, of course, things that are like aggregate counts. So it's much easier to get access to the number of people that got sick than, of course, individual medical records or scans or something like this, which still might be statistically useful or relevant for various things. And it's easier to get access to sort of simple statistics, and the big one for me is static data sets, right? So a very common paradigm, probably the most common paradigm as statisticians, is whenever we want to work with a data set, we acquire a copy, right? So as opposed to having, say, live updating data, right, where I have access to sort of the gold standard at a continuous basis, or the ability to do sort of dynamic queries against data sets, sort of the raw underlying live data set that's happening, inside of public or private institutions within my region, right? Or what if I wanted to do data joins across centers? Maybe I didn't want to know just how many people got cancer. Maybe I wanted to know, like, how many people who went to this particular cancer screening center ended up being treated for cancer at this other center, right? And I needed to be able to do some sort of complex data join across multiple different centers. Like this is quite challenging, especially if each of those centers are only just reporting to me high level statistics, right? And so this brings us back to the question, like, is it possible to answer questions using data we cannot see? Because if the answer to this question is yes, then it means that there's the potential for a much more sort of precise and live updating and flexible sort of data ecosystem infrastructure that can support us as statisticians and data scientists in the work that we do. And that is what this sort of course series is about. So I'm going to sample a couple of different topics using tools from a community called OpenMind, who we partnered with for the construction of the course. So I lead this as a free open source community sheltered under a charity inside of California, so a 501c3. And then they focus, broadly speaking, on privacy preserving techniques, both education for and free open source software for it. Today, I'm going to walk through a couple of examples from the course that use a library called SIFT. So if you want to see that, you can check it out here. And the first one that I want to give you a sense for is called remote execution. So in the course, we have several basically sort of lessons, sort of video style, and then we also have sort of code examples that people will walk through using a tool like this to sort of really embed the sort of education portion in a sort of realistic statistical setting to try to kind of bridge that gap between sort of learning a bunch of things in a slide deck and sort of getting your hands dirty and sort of doing it and preparing for the course projects. So the first one we're going to talk about is remote execution. So let's say, for the sake of argument, I'm going to use a statistical package called Torch, but I could use any Python library. This could be NumPy or Pandas or what have you. And the first thing that we teach students how to do here is have this notion of a remote worker, right? So as soon as we try to abandon the idea of always obtaining a static copy of some data set or a static copy of some high aggregate level statistics, then because we don't like that the data set goes out of date, we don't like that we can't work with the really personal data that actually led to this high level statistic, and so it sort of limits us in some structural ways. Then if we want to work with a remote data set, we've got to have some sort of reference to a remote actual location. So in this case, let's say there's a place called the May Clinic, and now I've got some sort of, as a data scientist or as a statistician, a data structure that is pointing towards, is giving me the ability to manipulate code within this data center. So this is a pointer to an actual server sitting in an actual hospital somewhere, and that server has data in it, right? And And the interesting thing here is that I have limited access to this server. So the idea is that, you know, I can perform some computations against it, but not all. But we'll get to that in a moment. And the cool thing here is, so let's say I have a list of numbers and I send that to the hospital data center. What gets returned back to me is this pointer, right? And with this pointer, I can do arbitrary statistics and data science inside of this private institution within my region, right? So again, instead of going to May Clinic and saying, hey, you know, once a year, I want you to send me a CSV file with these statistics in it because this is what I want to know once a year, right? Instead, you know, the May Clinic is continuously updating some sort of live set of data sets inside of their institution. And the idea is that I can do arbitrary data science against that database without ever actually having to necessarily see the data myself, right? So in this case, you know, when I do y equals x plus x, and I'm just it actually sends a message into the worker, executes it, and returns a pointer back to me, right? And so in the context of the course, you know, people will students will actually even get paired up with each other, and one of them will pretend to be the data center, and they'll spin up a little server on their laptop, and another student will pretend to be the data scientist, and the data scientist will connect over peer-to-peer connection to do sort of little exercises like this between different students, which is super exciting. So if we have remote execution, this is pretty nice, but this still opens up another problem. You know, how do we good data science or do good statistics when we actually can't look at the data ourselves, right? Now we have the ability to manipulate remote data sets without looking at them, but how can we be sure that what we're doing is actually sensical, right? And there's a few features that we'll go through. So the big ones are like search and example data. So let's say we have, again, you know, a client attaching to a remote institution. I can do some distributed search, and the essence here is this is because metadata doesn't necessarily need to be private, right? The notion of what data sets are available can still be sort of revealed to me in such a way that I can have pointers that are given to me, and I'm able to manipulate those pointers like I did in the last example. So in this case, you know, I've got a data set, and I look at the description, I can see how the data set was collected and like what's sort of in the data set. But again, I'm not actually looking at the private data or the commercial data or what have you. And when I say private data, I don't always just mean, you know, sensitive from like a privacy standpoint, but I also mean, you know, hey, maybe this data couldn't leave the Netherlands or couldn't leave Germany, and so the physical copy of the data just can't leave the border, so it needs to stay inside that institution, but I still want to be able to work with it to learn high-level insights. Or maybe this data is actually sourced from a private institution, and that private institution was really worried that it might get into the hands of another private institution that would compete with them. So it has nothing to do with it being private and sensitive, and more to do with it being sort of a competitive nature. I mean, this is even true in academia. Like if an academic comes up with a really valuable data set, often they won't put it online because they want to be the ones who sort of have lots of great publications based on this data set. So all sorts of reasons why someone might not want to share a data set with you. And the idea is that we can create sort of diverse tools, and we as statisticians can be more effective at our jobs if we have the ability to work with data that we don't necessarily obtain a copy of. So in just a few examples of features that we go through in the course. So this doesn't obviously solve everything, because we can still, you'll notice, I'm gonna go right back here. I glossed over this a little bit, but I had this pointer to remote data, right? So I took a list of numbers and I sent it to the hospital. I did some computation, and then I asked for the result back, and it just came. It just arrived, right? This is potentially dangerous, right? Because it means that, you know, what if this was a pointer to an actual sensitive data set, not a pointer to a tensor that I had sent there previously? You know, could I just download the results? Like that should have like sort of created some sort of red flag or bell maybe in your head that you saw when you were watching it. So now we're going to address that really quickly. And again, this is I'm going to go through this really quickly. This is the kind of stuff we dive quite deeply to in the course, but I just want to give you a bit of a sample. So for those of you who are not aware of differential privacy is a way to make it so that it's difficult to reverse engineer the outputs of statistical analysis, reverse engineer the inputs of the statistical analysis from the outputs. So for example, let's say I have a database. The database has a bunch of people in it and some sort of true false value, right? So the idea with differential privacy is I should be able to query this database and, you know, in theory, not be able to learn the sort of values of any one of these rows, right? And our definition, or our intuitive definition of perfect privacy would be where, you know, if the output of our query, meaning the output of our function on the database, is the same between this database and any identical database with one row removed or replaced. Meaning if we remove someone from the database and replace them with someone else, if the output of our query against that database doesn't change, then we know that the output of our query is not conditioned on that person, right? It's not specific information to that specific person. And if we can prove that for everyone in the database, then we've achieved sort of perfect privacy. And to the degree to which we can achieve that is some granular definition of privacy. But to give you a little more of an intuitive sense, I want to reference the social sciences. So if for those of you who might be from the social sciences, let's say you needed to do a survey and you needed to ask something that was like really taboo. You need to ask something that people might be likely to lie about. So you need to survey, you know, how many people are participating in some kind of illicit or illegal behavior, but you still wanted to know high-level statistics, but you're not a police officer, you're not trying to arrest anybody or whatever, you're just trying to understand it as, say, a sociologist or a psychologist. And so what you might do is you would go around with your survey, you'd ask a true/false question. You know, do you consume this illicit drug, or have you ever crossed the street not at a crosswalk? Some sort of mildly illegal thing, I guess. And what you would do is you would give each person a coin, right? And you'd say, hey, flip this coin twice in some area that I can't see. And if the first coin flip is a heads, I want you to answer my question honestly, true or false. And if the first coin flip is a tails, I want you to answer my question based on the second coin flip, right? So if the first coin flip is a heads, answer truthfully, yes or no. Do you jaywalk, or have you stolen money or whatever? If the first coin flip is a tails, answer true or false according to the second coin flip. So this means half the time people are going to be answering honestly, and the other half of the time they're going to be answering according to a perfect 50-50 coin flip. And the nice thing about this is that you don't know which person is answering honestly and which person is not, but you can reverse out the average of the distribution from this combined distribution, right? So what is this actually going to look like in an interface like this? So let's say I've got a pointer to a remote data set, and I try to download that data set. Oh, whoa, holy cow, don't do that. You just requested a data point, which is private, or which depends on data, which is private. You can only query private data if noise is added. Use .get epsilon to add the appropriate amount of noise, right? So this notion of epsilon is the ability for me to spend what's called a privacy budget. What a privacy budget is going to do is it's going to add a certain amount of noise to the result that I get back, so that there's a certain degree of plausible deniability to all the individuals who might be in that data set. So again, applying the same kind of guarantee that I mentioned a second ago. And so then I might pass in epsilon of 0.1, and then this returns sort of results back to me. And the idea here is that me as a statistician or data scientist would be limited to the amount of epsilon that I can spend as a result of my entire data science experience, or my entire data science experiment, right? So the data owner might give me, hey, you're allowed to do this experiment with up to 2 epsilon, and you can do whatever querying you want as long as you stay under 2, right? And then I'm like, okay, cool. So then I log in, I'll learn about trends in finance, or trends in business, or trends in healthcare, or trends in energy usage, or whatever it is that I'm looking to study. And as long as I stay under my privacy budget, everything's okay. So this is all pretty cool. But you'll mention a minute ago, I mentioned joins. What if I want to do a join across multiple data owners? So the last tool that I'm going to give us a quick little sample over is called secure multi-party computation. So again, these are just samples. If this is going too fast, that's totally okay. But I just want to give you a sense for what the course is about. So secure multi-party computation, the definition is like this. So multiple people can combine their private inputs to compute a function with or without revealing their inputs to each other. It's kind of wordy. This is what you'd see on Wikipedia. But more intuitively, I want you to think about it as multiple people can share ownership of a number. Okay, share ownership of a number, right? Let me show you what this means. So let's say I have the number 5. That's my face. And I split this number into 2 shares, almost like shares in a company or shares in a stock, right? And I'm going to give these 2 shares, notice the 2 and 3 add up to 5. I'm going to give these to my 2 friends, Marianne and Bobby, right? And then I'm going to disappear. And so now between Marianne and Bobby, the number of 5 is actually sort of exists, but exists as a combination of their shares, 2 plus 3 equals 5. Now, the actual, it's actually, but all shares added together modulus a large prime, but we're just going to ignore that for a second, okay? And the cool thing about this number being between Bobby and Marianne is, first, neither of them know what this hidden value is, right? Because neither of them can look at their own share and know for sure what value is encrypted between you. You have to have both shares. Like the other person's share could be negative 2,565,000,003, right? There's no way to know. The second one is that the number can only be used decrypted if everyone agrees, right? Which means that this number is under shared control by all the shareholders. Pretty cool. But the most extraordinary part about secure multi-party computation is that it's possible for both Marianne and Bobby to compute over this number while it remains encrypted and shared between them, right? So for example, if Marianne took her share and multiplied it times 2, and Bobby took his share and multiplied it times 2, the shares that are created as a result now represent the encrypted number 10, which is sort of, between them or a function of their shares, right? So they just multiplied their encrypted number 5 into the encrypted number 10 without having to reveal the number to each other. So there's a huge range of different protocols that allow you to do all sorts of interesting things with secure multi-party computation, with different types of security guarantees and different algorithms that you can and can't do in various settings. But I just want to give you sort of a taste of what secure MPC is about and what will be covered in the course. And of course, statistical models and data sets are just large collections of numbers which we can individually encrypt, right? So if you think about, a data set that you wanted to have multiple different people have sort of joint governance over, you might secure MPC share it across yourself and a hospital or across 10 hospitals or whatever else. It's like an interesting tool. And then we walk through several examples of how you can do this in practice with the open source tools that we work with. So in this case, this is a training and neural network. And there we go. So just a handful. Again, this is not all the techniques that are covered in the course. Just a small sampling of them. This brings us back to kind of the final question. Is it possible to answer questions using data we can't see? And the answer to that question is yes, if you've taken the course and you learn how these techniques work. So let's talk about what the course is about. So the course is broken up into 4 parts that are in increasing complexity. So the first one is called Our Privacy Opportunity. And this one is, I think, most surprising because it's totally non-technical. And it's basically about the idea that privacy-enhancing techniques are just a bunch of alphabet soup. I mean, think of the words that I just listed off: secure multi-party computation, differential privacy, federated learning, homomorphic encryption. I mean, it's just massive, very specific kind of pieces of the privacy puzzle. And what this first course called Our Privacy Opportunity is trying to do is trying to say, okay, forget about the technology for a second. When all these different pieces come together, homomorphic encryption, differential privacy, all these different things, what is the end impact to society? Like, what is the actual goal that we're trying to do in general, right? And so this is like a short introductory course that is for technologists, but it's also for like business people or regulators or legislators or decision makers who want to understand, hey, at the end of the day, what is going to happen as a result of privacy? Like, what is this privacy preserving technology actually all about? And then the next course, Foundations of Private Computation, which is being, so the first course was released on January 2nd. This course, Foundations of Private Computation, is going to be released next Tuesday. So if you're interested, definitely check it out. And this is the deep dive into all the technical algorithms that I was just showing off. And we're going to be releasing 1 to 2 lessons every week for the next 6 weeks. So we're starting off with federated learning and split learning, which are 2 different ways of achieving partial input privacy, for those of you who are familiar with the term. But this is all going to focus it in kind of a lightweight environment. So this is going to be, you're going to build a homomorphic encryption algorithm from scratch. You're going to build federated learning from scratch. You're going to do differential privacy from scratch. You're going to hear from some of the experts who invented them. So like an interview with Cynthia Dwork, an interview with Samir Wag, who invented one of the fastest secure MPC algorithms for machine learning, and several other experts in the field. But you're not necessarily going to learn how to put it into production in this sense. It's all about really learning the fundamentals and the foundations that sort of give you the ability to understand the core algorithms that you're trying to use. The third one, however, this one builds upon the previous one to say, okay, now you learn the algorithms, that's cool, but I don't want to build them from scratch all the time. Now I want to use a tool. This is about how you can deploy federated learning across enterprises in the cloud. So we'll actually show you how to stand up a cloud machine, and you can put data into it and allow other data scientists to study that data without them ever having access to it, and show you how the management works, how the scaling works, and really empower you with the tools and techniques necessary to actually facilitate the type of federated learning across enterprises that we as statisticians, really want to be able to do. And the final course is sort of a specialty course focusing on federated learning on mobile, and when I say federated learning on enterprises, I mean federated learning with all the bells and whistles you need to actually make it work, meaning differential privacy, encrypted computation, like sort of the sort of full package in terms of sort of remote data science. And then federated learning on mobile is actually sort of specific about saying when the server hosting the data is a mobile phone, you're building an app to do it. There's sort of special needs around, because phones are constantly logging on and off the internet, and they have sort of limited resources. You got to watch out for battery usage, and also, and you're often working with different languages, so it's like a little bit different. So why it's a special course for that. So hope you find these courses really interesting. They were developed in partnership with some really great partners like PyTorch, which is a great AI toolkit, Facebook AI, University of Oxford, the Future of Humanity Institute, also at the University of Oxford, obviously the UN Global Working Group, and the Privacy Task Team, and then OpenMinds, who contributed a great deal of content and the libraries. So if you're interested, check out the course. You can go to courses.openmind.org, and you can see more about how to register. And of course, if you have questions, I'm happy to take questions now. And if you have more questions, always shoot me a direct message in the Slack, and I'd be happy to happy to answer any questions or point you along the way. So yeah, thank you for taking the time to chat, and happy to answer any questions.
Thank you very much, Andrew. There's actually a number of questions already in the chat. One is it legal to get data from a remote institution? That's the first one. Second one is, can you say something on audit, quality assurance, and repeatability? These are typical challenges for official statistics. And then a question also, is this the same principle of Bitcoin technology? So is it legal? What about audit, quality assurance, and is it a Bitcoin system?
Ah, brilliant. So is it legal to get data from remote?
Maybe you could stop sharing your screen.
Oh, yeah. Sorry, my apologies. How about that? You see?
Yeah, okay.
That works?
Yes, that's good. That's fine. Yes, thank you.
Yeah. Awesome. Yeah. So on the is it legal question, so obviously this is a hugely domain-specific question. So within Bureau of Statistics, I think one of the core things that we do is obtain data from various institutions and aggregate it and help drive public policy decisions and these kinds of things. So obviously there's a limited legal framework in which that is done, where there are best practices that for data sets that we can and cannot do. Cases of where it might be illegal too are sort of things where it's maybe it violates GDPR or HIPAA, or it's crossing a geographic boundary where there's specific regulations saying that it can't be. And so I think that the essence here is really to offer a set of tools that make it possible to facilitate high-level study, wherein, especially in the cases when the low-level data itself cannot be actually fetched from an institution. So I guess the answer is both yes and no, and it depends on the context. And this tool is I think these sort of whole notion of privacy and techniques is trying to offer sort of more flexible options than either can I get the underlying data or can I not get the underlying data, which is a bit binary and sort of inflexible.
Okay.
Yeah.
And then there was a question on audit and quality assurance and repeatability.
Yeah, phenomenal question. Obviously there's a certain degree of sort of visceralness when you actually get a copy of the data, where it's like, okay, if I'm storing the data, I know that it's not going to change, and if I'm storing the data, then I can look at it, and by looking at it, I can get some kind of sense of its quality. So those things certainly change when you start considering remote execution. So when considering repeatability, this one I think is probably the easiest one to specifically address. So under the assumption that sort of everyone in the data network that you're working with are sort of responsible, trusted intermediaries, this type of system can still provide you the ability to sort of verify that you're working with the same data set that you were previously. For example, obtaining a hash of a remote data structure, I think is probably one of the best sort of simple tools to be able to make sure that you can repeat the same experiment that you did previously. In terms of auditing, I think that this really relies on kind of the same fundamental auditing techniques that you would have used previously, but it's more likely that auditing process will need to be shared between you and whoever is hosting the data. There are really powerful tools that can help with that auditing process. So for example, zero-knowledge proofs are really great for being able to verify attributes of the data set that you can't physically look at yourself. So the sort of functions that can make sure that it's full and complete and actually has all the fields it's supposed to have, and they're formatted in the correct way, and like so all these kinds of things you can verify without actually seeing it yourself, which is pretty cool. In terms of quality assurance, obviously, I think some of the same techniques apply, but it depends on specifically what quality you're looking for. That I would, in order to be able to speak directly to it. But I would say that the things that you're addressing are exactly the right questions to be asking, and I think the most interesting kind of if we consider where the field is coming from in terms of like homomorphic encryption is kind of in its own world, like a homomorphic encryption library, and like secure MPC is kind of in its own world with secure MPC libraries, and federated learning is kind of in its own world. That's sort of like these individual ingredients. What the OpenMind community is mostly focused on is saying, okay, if each of these individual ingredients need to come together, what is the end-to-end sort of product experience that combines them? That answers really important questions like audit and quality assurance and repeatability. So I think in this case, if you're familiar with where the privacy tech community has been historically, I hope that you would find it extremely refreshing to see sort of more of an end-to-end product that's sort of focused on a user as opposed to focusing on algorithm, which I think is where most of the infrastructure has been previously. And then there was a third question.
There was a question about Bitcoin technology.
Oh, yeah. Same principle as Bitcoin technology. So there are some overlapping subcomponents. So specifically cryptographic signatures is used a lot, which is a really, really big part of Bitcoin technology. There are some people that use distributed ledgers as an audit ledger for these kinds of techniques. We aren't focusing on that in this particular course because it's a little bit of a different problem. So for example, like proof of work or proof of stake is really about enforcing who pushes something into the database first. And that's sort of less of an issue for distributed statistics. But there are certainly components underneath it that are very similar. So from that perspective, there's certainly overlap.
Thank you very much. And we are like very close to the time limit. So once again, thank you very much for the presentation and for the questions. I have learned a lot today about the achievements that has been achieved by the task team on training and the other task teams that's been working with training activities. We are much closer to having a lot to offer than I actually knew. So this is kind of very nice to know. So I think my conclusion will be a conclusion that my former boss often used, namely, watch this space. A lot will happen. So thank you very much, everybody, for participating. Thank you for the presentations and your active engagement in this side event. And looking forward to meet you somewhere in the training areas that we have outlined today. Have a nice day, evening, or morning, wherever you are. Thank you very much, and bye-bye.